Thanks. Then we have the final speaker, Pieter Jan, together with colleagues. Another success story.
Thanks. Not yet. Good afternoon, everyone. We're from Project Mahi. I'm Pieter Jan. This is Bertold. This is Julien. So we'll be presenting our project called Mahi today. Let's see. So the reason why are we here? I said it before. It's interesting for us to present our project, to see if we can find some interesting partnerships and possible also some sponsors. So in the next 15 minutes, we'll present our project. We'll briefly talk about the technology and also present our view on future applications for autonomous vessels. So in the next few slides, Julien will present our project.
Thank you. So let me introduce Project Mahi to you. So what it's all about, the main objective of Project Mahi is to build an autonomous unmanned surface vehicle to cross the Atlantic Ocean. So why are we doing this? Because to our knowledge, no one has done it before. It will be the first time. So who's behind this project? We are a team of 4 engineers, 4 engineering friends. We met each other at the KU Leuven during our studies. So Pieter Jan, Bertold, and me, Julien, are present. Andreas couldn't make it today. Andreas has a master in energy engineering, and will focus on the energy and propulsion of our vessel. Bertold has a master in electrical engineering and also a PhD. And he's an expert in embedded systems for the vessel. And Pieter Jan and I, we have both a master in aerospace engineering, and we will take the naval architecture, navigation, communication, and sensors to our account. So a little bit more about the route. So Project Mahi will start in France, in Les Sables d'Olonne, and we'll go to Guadeloupe in the Caribbean. So the first challenge of the vessel is to cross the heavy traffic lines from and to Western Europe. We have to avoid collisions, of course, and for that we have sophisticated algorithms based on an AIS system, but Bertold will tell something more about that later in the presentation. When we have crossed the heavy traffic lines, we will go south towards the Azores before crossing the Atlantic Ocean. Going south is done for several reasons. The first one, we want to avoid floating debris in the North Atlantic gyre. Second, when we go south towards the equator, we reach the more sunnier parts of the ocean, which is good to charge our batteries because we will have solar panels on our boat. And last but not least, in the southern part of the ocean, waves, current and winds travel from east to the west, so which is good for our trip. We estimate that it will take about 80 days to complete the trip. Something more about data acquisition. We have some vessel data. So that's our location, our speed, heading, battery status, structural integrity. We'll upload all these data to our website together with sensor data. So it's atmospheric data, temperature, but also oceanographic data like phytoplankton activity, salinity, temperature, and so on. We upload it to our website where everyone can check it online, so it's on projectmahi.com. It's an interesting website also at this moment because we have also a crowdfunding page. So if you have a lot of money and don't know what to do about it, just give it to us, we know what to do about it. Then the timeline and some milestones. So it was Pieter Jan who came up with the idea in 2015. So maybe we can build an autonomous boat and cross the Atlantic Ocean. I said, okay, yeah, that's a really good idea, but it should be unmanned. So in December of 2015, we started with the construction of a prototype. Why a prototype? 2 main reasons. First one, we wanted to use composite materials, and we hadn't really much experience with it, so we wanted to test it in a prototype before making the final vessel. And we also wanted to test our first algorithms with GPS waypoint navigation. Okay, so we did some lake trials in September, and in November 2016 we had our first test on sea near Sable-d'Olonne in France. You can see a picture of the prototype. In January of this year, we started with the construction of the final vessel, and in November of this year, it will be ready. So we have 2 more months to start testing on a lake. Next year, at the beginning of next year, we will do some tests on sea, with final tests in April, and we will launch in May. Why May? Because we want to be ahead of the hurricane season. That becomes quite difficult. Okay, and then I will give it to Bertold.
Okay. Hello, I am Bertold van den Bergh. I am responsible for implementing the embedded system in this sea drone. So first I will talk a bit about the general technology where the boat is made of. So it's a composite vessel. It's made of basalt fibers, and they're made in the composite material using a bioepoxy, and the core is from polyethylene. And then to move the boat, we'll use an electric motor of 2 kilowatts we got from Torqeedo. Now actually this power is way too high. We will never use that because also we are limited in the amount of solar energy we can obtain, but this was just chosen because to have a good motor with a metal gearbox, we also typically came into this very high power range. And then to generate the energy, as I already said, we will use an array of solar panels that are installed on top of the boat. And also we will have 2 sets of battery packs for redundancy and also to have a higher capacity. And to connect the boat to the shore, we will use a satellite link. We are thinking both of using Iridium for very high reliability communication because they have a coverage of the whole ocean because they have a mesh network between their satellites. And then we will use Globalstar for less important communication, for example, sending pictures, maybe even short videos because the traffic cost is much cheaper. But we cannot guarantee that we have coverage over the entire trajectory. And then of course for navigation, the primary thing we will use is GPS to know the position of the boat, but also we will augment this with a compass sensor and also accelerometer data to know the orientation of the boat. While this is useful for the navigation algorithms, this is also data that can be used, for example, to estimate wave heights, wave frequency, etc. To avoid collisions with other boats, we are primarily looking at the automatic identification system, which sea-going vessels are required to be equipped with, which transmits their position, and we can use to know where they are and try to avoid to come into contact with them. And of course, navigation lights, because they are required. We will have them on our boat, but we cannot detect it from others. And then of course, there will be an autonomous system that will steer the boats towards the trajectory to hopefully arrive in the Caribbean. Yeah, then of course, we will also try to collect some data which is not really related to the boat itself, but it can be useful for other research. And first, we will have 2 types of sensors. One will be in the atmosphere, and the other ones will be underwater, because we are just at the interface, which is very useful to collect 2 types of measurements at the same time. So then the first things we will do is wind speed and direction, the air temperature and the air pressure, the CO2 concentration in the air, and the light intensity, which we get from our solar panels. Then of course we will also put a camera to make some photos. It's probably not that useful, but it's very, very nice to have to show on the website. And the sensors we will have underwater are the temperature of the water, the salt concentration in the water, also underwater sounds, a CO2 concentration that is dissolved in the water, and also a camera underwater to check the state of the boat and see if there is some interesting things. And then we will upload this information also through our satellite link.
So in this last section, we'll briefly talk about the steps we've taken in the project so far. The challenges we've encountered, and then a future plan for a possible business. So the idea, it started in 2015, where we had the intention of building an autonomous boat with a group of friends, and of course to send it across the ocean while doing measurements. We brainstormed a lot during the first few months. We had crazy ideas on how the vessel should look like, what the timeline should be, how we would get funding for this project, and of course what the name would be. So basically we had to start from scratch, a blank page, and we had to build the project step by step. So after a few months of setting out a rough guideline and planning to get the project started, we were very enthusiastic about the project, so we wanted to find some funding with industry sponsors and other people. So we started writing lots of emails and sending them out, but unfortunately It does not work that well as we hoped for. We hope to be millionaires by this time already. But it goes a bit slower than that, so we had to, we noticed that we had to do something to make it more tangible. So Jules already explained that we will build a prototype, that we can make some videos, some pictures, and it's for people very attractive to see pictures and they can see the boat. So we started doing, started with the prototype on our own funding, but we also started a crowdfunding campaign on our website to get, let's say, some friends, family, and just generally enthusiasts involved in the project. So up till now, we reached almost 3,000 euros with our very, let's say, modest crowdfunding campaign. But we also, at the same time, we still send out emails because we can't help it. We need to send out emails to companies as well to get them interested in our project. And by this time, we already have a couple of sponsors as listed above me that are behind the project. So next year in May, we will launch our final vessel. The boat will cross, let's say, hopefully cross the Atlantic Ocean and do some measurements at the same time. After that, we are considering to start possibly a small company and see what we can do, because we know that there are lots of applications for these autonomous vessels. We just chose one of the applications for this project, which seemed to be interesting to us, because then we get to fly to Guadeloupe and drink some beers on the beach after we picked up the boat. So we see lots of applications, and that's the last slide I want to quickly show to you. Actually, we consider our vessel to be sort of a platform onto which we can put different sensors, different equipment to perform a range of different tasks. So the first one is Mahi the Inspector. So basically, we've just put a bunch of cameras and sensing devices onto the vessel, and it can be used to inspect remote or biosensitive locations. An idea would be also to put a drone on there and start to check out the offshore wind farms, as mentioned before. That's one of the applications. Then the surveyor, it can be equipped to survey and chart coastal waters. So this data can be used to optimize dredging activities. So there's a lot of interest as well from this angle to improve the activities. Also, basically an extension of our project is Mahi the Oceanographer. We can put atmospheric and oceanographic sensors on there to remotely monitor our rivers, seas, and oceans, just to check the health of our environment. And then the last one is the transporter. We can, like a drone can fly packages from point A to point B, we can also do transport. So that was our presentation. I wish to thank everybody for their attention, also to thank our sponsors for their support, and of course the invitation from EMODNet that we can present our project here today. So if there are any questions. Yes?
You've got an AIS on it, so, but you can also pick up the AIS from other boats. Do you take active measures to avoid collisions?
Yeah, that's the idea, but I'll pass on the mic to Bertold.
Well, yes, that's the main point, because actually we don't have an AIS transmitter, because it's quite difficult legally, but still we can receive from the other ships and we can take evasive action.
Not like the American destroyer that, that crashed the other day. Okay.
We try to avoid the vessels.
What perks do we get when we give you money on the crowdfunding campaign?
We can think of very interesting, let's say, arrangements, but perhaps we talk about.
I don't have a lot of money, but maybe you can tell it.
Perhaps the other guys, yes. But yeah, our project it's just the start of something. We can find, of course, some arrangements to
like
make
a speaker shouting your name all the time on the
yeah,
missions.
yeah.
But we have some nice rewards.
Yeah.
How long will the trip take, approximately, you think?
Julien, you mentioned it's approximately 80 days. It can be less, it's a conservative estimation, but the reason why we launch in May is just to be after the, let's say, the winter season in Europe and before the hurricane season in the Caribbean. So, but it will take more or less. It's quite a slow boat, but of course, if you want to do measurements, if you have high speed, it doesn't always work that well. So.